Hello everybody, how's it going? We are at Unit 4, Section 5. Should be Monday night. You should be watching these on Monday, October 8th. Hopefully you will. And this is Unit 4, Section 5. We're going to talk about right triangles and some proportions that are in right triangles. And we actually do have a right triangle theorem right here. The right triangle theorem says that if an altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to each other and to the original triangle. So here is a picture of that. I drew an altitude. An altitude is a height. And I drew it from the right angle, directly 90 degrees to the hypotenuse. And it broke the hypotenuse into two pieces. One piece is 1.6 meters. The second piece is 3.6 meters. And we're calling the altitude x. We want to try to solve for this x right here. Now actually what it does is it breaks it into three similar triangles. You could probably see the small triangle right here. It's triangle ADC, so let's label this one right here. So D is my right angle, so that's going to be right here. D. Oops. And then angle A is this little right angle down here on the short side. And then the long hypotenuse, and then the longer side is up here at C. So that's my small triangle. Now of that small triangle, I have the 1.6 is this bottom piece right here. 1.6 meters, and I have x as my other leg. Now, as far as the medium-sized triangle, that's this triangle right here. See, the medium size. That's going to be angle D again is my right angle. And angle C is off the shorter side this time. And angle B is off the longer leg and the hypotenuse. This is B up here. And the pieces that they give us this time are the short leg X, and we've got the long leg 3.6. Now the big triangle is the whole thing. So C is the right angle. And the short side is where A is. So it's like turn, you could like flip it up and it would be here. So A is down here, where the short leg is. The short leg right here is this short leg over here. And then B is up at the long leg. So this is B. So those are all the three sides of the three similar triangles. And they're similar meaning they have the same angles and they have proportional sides. So if you look at these two right here, if you take a look at these two similar triangles. Here, so you can see it. So if you check these two out, you could see that they have corresponding pieces right now. They have the back side and the back side, and they have the bottom side and the bottom side. So if I wanted to make a proportion right now, I could put x over 1.6, and then I'd have to put 3.6 over x, or I could put x over 3.6 equals 1.6 over x. What I'm actually going to do, though, is I'm going to start at the bottom here, and I'm going to put 1.6 over x. I'm going to do my small triangle over my big triangle, so I'm going to need to do my small triangle over my big triangle. So here's my small triangle over my big triangle. I'm writing with my mouse, so it's a little tougher. And these are equal. These are two equal ratios because the two triangles are called similar. That's supposed to be a similar symbol, and it doesn't look that great, so I'll do another one. There, a little better. Now, if you were to combine your multiply your diagonals here, you would get x squared equals, and then you'd have to multiply 1.6 times 3.6, so Let's grab our calculator and do that. 1.6 times 3.6, and you get 5.76. Whoops, it's not there, my bad. 5.76, it's still not going there. Where is it? 5.76, okay. So you get x squared equals 5.76. Then what you want to do is you want to square root both sides. So you would take the square root of this side and the square root of this side, and you would end up with x equals, and let's see what the square root of 5.76 is. 5.6, and we want the, no, that's not what I want. Oh, there it is. 0.76, and we want the square root, so 2.4. So it comes out to be exactly 2.4. It is 2.4. And it would be meters. So that would be your x right here, the 2.4. Now I did give you a term before in our notes, and it was a while ago. Most of you probably won't remember it, but it was called the geometric mean. And the geometric mean is the square root of the product of two numbers. So if you look at this proportion right here, we multiplied these two and got the x squared, and then we add these two. So really what we're doing is we're taking the square root of the product of these two numbers. We multiplied these two and then took the square root of it. That's called the geometric mean. And you can remember these two right here, these two places in our proportion are called the means. So it's therefore we have what we call a geometric mean, these two places right here. Now the geometric mean could be the third root of the product of three numbers, the fourth root of the product of four numbers, or in this case the nth root of the product of n numbers. But here's the proportion that always works. Your x's are going to be your means, your two numbers are going to be your extremes, x squared is going to equal the product of those two, and then you square root both sides to get your answer. The altitude to a hypotenuse in every right triangle is the geometric mean of the two segments of the hypotenuse. This piece is the geometric mean of these two pieces. This piece will break it into proportional sides. So that's why it's a geometric mean. Let's look at a quick example here. Find the geometric mean of 4 and 5. So the proportion that you want to set up would be 4 over x equals x over 5. Remember, the geometric mean is the product of the square root of the product of these two numbers. So we're going to multiply x times x and get x squared. And then we're going to multiply 4 times 5 and get 20. And then you're going to square root both sides, and you'll get x equals, and you probably remember how to break that down, radical 4 times radical 5. So really you would have 2 radical 5 for your answer, or you could get a decimal, but 2 radical 5 is fine. So when you want to find the geometric mean of two numbers, you put the x in the mean places, in the two places where the means are, because you're going to multiply those to get x squared. You multiply the two extremes, and you get your number. You take the square root of the product of these two numbers, and you're going to end up here with 2 radical 5. So let's do a few practice ones. Let's set up the equations for these. So that this number right here, 9, is the geometric mean of these two numbers. So this one's going to be a little different. You're going to end up having a 4 over 9 equaling a 9 over x. So this one is a little different in the sense that the x is not the geometric mean. This time the 9 is the geometric mean. So this time you're going to multiply 4 times x and get 4x equals 81. And then you're going to divide by 4 on both sides. And you're going to get like, let's see, 20.25. So that would be your x. x for that one. Let's see if we can set this one. This one, the geometric mean is your x. So you're going to do you need your smaller number. Usually we start with a smaller one, so it would be 2 over the x equals the x over the 8. Remember, the x has to be in the two mean places. So you have the x at the bottom of the first one, and you have x at the top of the second fraction, and that's where the two means are. Remember, your A, B, C, D. B and C are your two means. So that's where they go, right? In two mean places. So there's your proportion. So this time you're going to get x times x, you'll get x squared equals 16. 2 times 8 is 16. So this one will be an easy one. When you take the square root of both sides, you're going to end up with x equals 4. And oops, wrong one. You could put your square root on both sides. Square root both sides, you get x is 4. Okay, you try this one. Go ahead and pause the video and try it, see what you get, and then I'll go over it, but I want you to give yourself a chance first, see if you're learning it, see if you're figuring out how this works. So go ahead and try it and then come back. Hopefully you tried it already, and the geometric mean, I would put 10 over x, because it's 10 and x is the geometric mean, so you're going to put the x in the mean places, x over 10. So that's where that goes. You're going to make your proportion. And we could put equals in the middle of those two. So you're going to actually have another easy one here. It's going to be x times x is x squared. Equals 100. And then square root both sides, you're going to get x equals 10. So you could square root both sides. Now normally you would say when you square root both sides you'd say plus or minus 10, but in geometry this distance cannot be a negative, so we just use the positives. Alright, let's try this one. Maybe you could try it on your own if you want to. Go for it. Pause the video, give it a shot. This one we might use similar triangles instead. We could say that we have our small triangle here has the hypotenuse and the long leg. So I could make that a ratio. I could put my long leg. We could still use a geometric mean actually, because this is the geometric mean. It would be our x. You would have, no, you don't have the two pieces here, so that would be a little tougher, because you could put 16 minus x, but that's going to be, this is already x. So what we're going to do is we're just going to use the similar triangles. We're going to do long leg over hypotenuse. So long leg x over hypotenuse 9. And that's for my little triangle. Long leg over hypotenuse. Keep that in mind. I use the long leg of the little triangle over the hypotenuse of the little triangle. Now I need to find the long leg of my full big triangle. My long leg here is 12. It's going to be long leg over my hypotenuse, and my hypotenuse is 16. Those two have to be equal ratios. If you're consistent and you know that triangles are similar, then you know the sides have to be proportional. So if I go ahead and put the long leg over the hypotenuse in one triangle, then I can put the long leg over the hypotenuse in the other, and it will work out. So here I would end up, I'd reduce this fraction to divide them by 4, and I get 3/4. So I would end up with 4x. 4x equals 27. And you would divide by 4. So x is going to equal like 6 3/4, so 6.75, or you could put 6 3/4. Alright, try the next one, see what you got. See what you think you can do there. This time we don't have the altitude to the right angle. Altitude is always at a right angle. Whenever you hear the word height or altitude, you know it's going to be at a right angle. So what we do have is a short leg and a hypotenuse. So I would put my short leg 4 over my hypotenuse 8. I'd probably reduce that to 1/2. And then I would put my short leg of the big triangle 8 over my hypotenuse of the big triangle, and the hypotenuse of the big triangle is x plus 4. X plus 4 is the whole hypotenuse. You may not have known what I did there, but to get this whole hypotenuse, I had to add, I had to add these together to get the hypotenuse. So 4 and x together makes x plus 4. So now I can solve it. I'm going to get 1 times x plus 4, which is just x plus 4, equals 16. And you're just going to subtract 4 on both sides, and you'll end up with x equals 12. So you solve it there, you get x is 12. Last, but definitely not least, we have the whole small triangle here. We have a 3, a 4, and an x. X is my short leg. So what I'm thinking is short leg over long leg. And that would also match up with short leg over long leg in the big triangle. So short leg is x over my longer leg in this little triangle is 3. Short leg, long leg, hypotenuse is across in the right angle. So x over 3. And that has to equal my short leg over my long leg. Short leg 4 over my long leg 10. That's going to be 4 over 10, which I'm going to reduce to 2/5 because I don't want to use 4/10 if I don't have to. So I'm going to reduce this to 2/5. So let's see, we're going to multiply 5 times x and get 5x equals 2 times 3, and that's 6. So you're actually going to get x equals 1.2 when you multiply, or when you divide both sides by 5. 6/5 would be 1 and 1/5, which would be 1.2. Alright, that's all I have for section 4-5. Think about the altitude to a hypotenuse, kind of what it means. An altitude is a height. It breaks a hypotenuse into 2 proportional pieces. This altitude is the geometric mean. It can go in the mean, 2 mean places. Alright, we'll see you guys tomorrow.